This video is about Introduction to Materials Management, and the topics we'll be studying in this chapter are manufacturing strategies and lead time. Here's a definition of materials management. Materials management is about planning and controlling the flow of materials. And by materials, we mean there can be different types of materials. For instance, inventory, it could be raw material inventory, which comprises components that are received from suppliers. It could be in process inventory that's undergoing transformation, and it could be finished inventory that's ready to be shipped to the customer. And the objective is to optimize the use of firms' resources because every organization has limited resources. By resources, we mean they can be financial resources, material resources, human resources, informational resources. So all these resources are limited, and we have to make sure that we are making the best use of those resources and providing the required level of customer service. In a nutshell, the objective of materials management is to streamline the flow of materials, which essentially means planning for materials, scheduling materials, and making sure that the flow of material between different entities within an organization and across organization is smooth. Materials management is important because efficiencies in this function is directly related to winning businesses. And more specifically, in business, there are two type of criteria that are important. The first one is called as order qualifier. So order qualifier means that these are characteristics that are essentially required in your product and in your service. If these elements are missing, you won't be even shortlisted. Some examples of order qualifiers include price, quality, and delivery. And as you can see that price and delivery, they are directly related to materials management. So price is directly related to material management, which means if an organization is efficiently managing their material, their prices would be competitive. And the second thing is delivery. If their material management, that's flow of material, is efficient, then delivery would also be streamlined. Quality is also related to efficient material management, but that's indirectly related. And the second category is order winners. And by order winners, these are the characteristics that convince a customer to select a product or service from a qualifying company. So these are the characteristics that differentiate a company from their competitors. And some examples of order winners include faster delivery time than competitors and customization options. Now, again, as you can see that both of these characteristics, that's faster delivery time than competitors and customization, are directly related to efficient material management. In the nutshell, efficient material management is critical to winning business contracts. Now we discuss some strategies, manufacturing strategies and lead time. The first strategy is called as make to stock. In this strategy, an organization would produce something in bulk so that it could be sold later. Manufacturer produces the goods in anticipation of customer demands, little or no customer involvement in the design, and inventory held as the finished goods. Let me give you an example. So in this case, the company will use their forecasting methods, and for forecasting, they can use different type of technique like moving average, weighted moving average, exponential smoothing, etc. So they will use forecasting technique to determine an inventory level, and then they will produce it and sold out to customer. So one example is that if you want to buy a laptop from Walmart or Best Buy, so of course, if you want to buy a high-end laptop, then perhaps Walmart or Best Buy is not a good place to buy. But the laptops or computers that are sold at these places, they are economic one. Now, when you buy a laptop from a Walmart or Best Buy, then there are two things. So first of all, they will be economic. But the second thing is that you don't have much options for customization. You can only buy what's available on their shelves. So for example, if a laptop that's being sold at Walmart, its specification is i3 processor, but you are looking for i5 processor or i7 or i9 processor, you cannot change it because that's not how things work. You have to pick up whatever is available on the shelf. You cannot customize it. So these are the characteristics of make to stock, which mean while on the one hand, a product is readily available and it's more economic, but your choices are limited. You cannot do customization. Then the next strategy is called as make to order. In make to order, the manufacturer does not start until the order is received. This is in sharp contrast to make to stock. In make to stock, a company has already made items, but in make to order, the manufacturer does not start until the order is received from the customer. They often use standard components and inventory is held as raw material. Some examples include custom tailored clothes and 3D printed products. Now, a 3D printed product, it could be made of plastic, it could be made of wood or metal. So, depending upon what are the required characteristics of the item, the product will be made accordingly. Similarly, customer tailored clothes, again, there can be different designs, there can be different type of fabrics. So, a manufacturer will not start producing it unless order is received from the customer. Then the third strategy is configure to order. In this case, a customer can configure products based on features and options. That's generally not the case in make to order. This one, it differentiates from make to order in the sense that in make to order, that was the previous case, over here a customer cannot configure, but over here a customer can configure. And it's also possible that a customer develops a configuration that's entirely new. It has not been done before. And in this case, manufacturing and assembly is required because configuration of the product is entirely different. So manufacturing and assembly would be required. And some examples are highly specialized, customized supercomputer that require manufacturing of some parts, or a custom sized bicycle for which some parts have to be manufactured. So this is called as custom to order. Now in custom to order, as you can see here in this figure, this is configure to order. In configure to order, as you can see here, that these are different steps. There's inventory and there's manufacturing and assembling and shipping. The process starts from manufacturing because every customer has a unique product because they can configure, and because every product is different. So this thing, their manufacturing cycle, or we can say this delivery lead time, will start from here. The second last is assemble to order. In assemble to order, a company has standardized components that are used to make standardized type of products. No design time required because all the designs are standardized, so lead time is shorter and only assembly is required. And this type of manufacturing strategy is used by Toyota, and it's a part of the Toyota production system, which means all the designs are standardized and they know the same type of engine, the same type of transmission will be used. And whenever an order is received, they would immediately start assembling. So that's called assemble to order. And if we can see over here in assemble to order, the delivery time or lead time starts from assemble because you don't have to do anything manufacturing. Standardized component have already been manufactured and you already have their inventory. Whenever an order is received, you just start assembling and then ship it. Now, here is a nuanced difference between these two approaches, that's assemble to order and configure to order. Because in assemble to order, it's only about assembling, so therefore it is possible that you can have standardized components. But in case of configure to order, because every customer has different requirement, so it is not possible to have standardization. So standardization does not apply in this case. Then the second thing is customization. In customization, configure to order, customization is possible because it's essentially about configuration. So customization is possible here, but over here customization is not possible because everything is standardized. Then in assemble to order or ATO, everything starts with assembly. As the name shows, assemble to order, which means you have standardized component and every time an order is received, you start assembling. So manufacturing or lead time starts from assembly. But in CTO, that's configure to order, it starts from customization before assembly. So when an order is received, first of all, because every order is different, you may need manufacturing, and after manufacturing, then assembly would start. An example of assemble to order is Toyota production system. An example of configure to order is a highly customized computer. Because it's highly customized, it means it would have some sort of component or specification that other computers don't have. So therefore, they would need manufacturing and assembly. And accordingly, lead time will be longer in this case. And the last thing is inventory level. In ATO that's assembled to order, it is possible to have high level of inventory because all the components are standardized. You know what type of components would be used, so you can maintain a high level of inventory. However, in case of CTO, where all components are different, we cannot have high level of inventory because different items have different components. So there will be broad range of components. So that is a difference between ATO and CTO approach. And the last strategy is engineer to order. Engineer to order, or also called as ETO, is applied to very unique type of products that don't exist in the market, which means you have to make them first time. So one example could be a barber wants to automate their business. Barber is looking for a machine that can cut hair automatically. And to the best of my knowledge, this type of machine is not commercially available at the moment. So if someone wants to develop this type of product, their delivery time, it would start from design, which means when they place an order, someone will have to design that product and then they will have to manufacture it and then they will have to assemble it and then ship it. So lead time will be very, very long in this case because product is unique and therefore lead time will be very long. Another example would be, imagine if you are running a bakery and it's a small bakery and you make donuts and croissants and one of the component used is eggs, and because it's a small business you daily use 10 eggs and it's not a big thing, you can break those 10 eggs that will be used as raw material. But imagine, no, if your business expands and every hour or every 2 or 3 hours you have to break 100 or 1000 eggs, and no, you are looking for a machine that can do all these things automatically, which means a machine that can break eggs and it's also able to separate egg white from egg yolk. And again, to the best of my knowledge, this type of machine is not currently available at the commercial level. But if you want to make this type of machine and when you place an order, someone will start with designing a product. So first they will design the product and then they will manufacture it and then assemble it and then shipment will happen. So again, lead time will be really, really long. By lead time, we mean the time when you place an order and the time it is received. The time between these two is called as lead time. When you place an order and when the product is received, that time is called as lead time. So here is a pictorial presentation of a comparison of these strategies. So for instance, the first one was make to stock. And in make to stock, we discussed that a company has already made everything in bulk. Whenever there is an order, they just need to ship it. So that's called as MTS or make to stock. So you don't have to bother about manufacturing, that has already been carried out. Assembly has already been carried out. Inventory, it's already there. Whenever there's an order, you just have to ship it. And that's called as make to stock. The example that I gave earlier is when you buy a laptop from a Walmart or Best Buy or other retail store. But as you can see here, although delivery lead time is very, very short here, extremely short. But the disadvantage is that you don't have many options. You have to buy whatever is available on their shelf. If there is a laptop having i3 processor, but you are looking for i5, i7, or i9 processor, you don't have an option. You will have to buy i3 processor if that is the one that's available. And then the next one is assemble to order, whereby everything starts from assembly, which means manufacturing has already been carried out, inventory is already there. Whenever an order is received from the customer, the company will start assembling and they will ship it, and therefore lead time is also shorter, although it's little bit longer than compared to MTS, but it is shorter than other approaches. And one example that we discussed earlier of this one is Toyota Production System, whereby components are standardized, they have already been manufactured, there's an inventory, and standardized components are there. And as soon as order is received, they would start assembling and they would ship it out. And the third approach was configure to order, whereby a customer can configure, they can change design, they can choose a design of their choice. Now, in this case, it will start from manufacturing because every design is different. So, therefore, this delivery time would be relatively long compared to assemble to order. So in this case, delivery lead time starts from manufacturing, which means once an order is received from customer, the company would start manufacturing and then assembling and then ship it. So that would be delivery lead time. And then this is make to order. Again, make to order is similar to that. And as we already discussed, the difference between MTO and CTO is that in MTO, usually there's not much customization, but over here, some customization is involved. And the last one was engineer to order, where I gave example of an automatic machine that can cut hairs or a machine that can break eggs to be used in a bakery. Now, because these type of machines, equipment do not exist, it must be made from scratch. So therefore, delivery time starts from design. So a company will design that product for you because design does not already exist, because it is a unique product, and then they will purchase all the components for that, and then they will manufacture it, assemble it, and ship it. And therefore lead time is very long. Now, material management and profits, we'll be doing some calculations to highlight the importance of material management, how material management contributes to profit, and some of the concepts that you need to remember. One of them is called as labor cost. So that is the cost, which means the cost associated with labor, the cost associated with volume sold, and there's material cost that varies with volume sold. If more products are sold, more material will be used. If more products are sold, there will be more material cost, and labor cost will also change accordingly. And then there is overhead that does not vary with volume sold. We will discuss a few examples whereby we'll see that why material management is so important. And again, material management is the flow of materials, managing materials, procuring materials, planning materials, and scheduling materials. Now, here's an example. A company, their direct material cost is 500,000. Their labor cost is 200,000 and factory overhead is 200,000. And total cost will be the sum of these three costs. So 500,000 plus 200,000 plus 200,000 will be 900,000. So their total cost is 900,000. Their revenue is $1 million. So their profit will be revenues minus cost. That's a formula we use. Revenues minus cost is equal to profit. So the formula for profit will be is equal to your revenues, which in this case is 1 million, and minus total cost, which in this case is 900,000. So our profit will be 1 million minus 900,000 is $100,000. That is the profit. So that's our starting point. Now we want to make some changes in these figures. Suppose we say that, oh, we want to reduce this material cost, which means we want materials manager to negotiate with supplier to seek some reduction in this cost. And again, these are the formulas. One of the formulas, profit is equal to revenue minus total cost. And this formula, it can be tweaked a little bit to convert it into revenues is equal to profit plus total cost. So going back to your high school math, you can add here plus total cost and also add here plus total cost. And this formula will become this one. Revenues is equal to profit plus total cost. And if the question is that if the price of an item is $50 and you want to reduce it by 12%, so you multiply it by 88. So 100 minus 12 is equal to 88%. So 50 multiplied by 88% is equal to 44. Another formula that we'll be using will be percentage change. How much change is happening? And for that, this is a formula that's current value minus previous value divided by previous value and multiplied by 100 to get percentage. Here is an example. And in this case, I want to highlight the importance that the job of material manager is so important that if they are able to reduce material cost by 12%, and how would they reduce this material cost by 12%? They can reduce material cost by 12% by efficient planning or by negotiating with supplier or by buying in bulk. In any case, we know that over here the direct material cost was 500,000, and if you reduce it by 12%, so which means we will multiply 500,000 by 0.88. We have 500,000, we are going to reduce cost by 12%, so 100 minus 12 is 88%, so multiplied by 0.88, it means the new cost will become 440,000. This cost, initially material cost that was 500,000, after this 12% reduction it becomes 440,000. Labor cost remains the same, overhead remains the same, revenue remains the same. And now we have to calculate how much increase in profitability happens. So we know this is the total cost of goods sold, and the only difference from this one and this one is material cost. Initially, this material cost was 500,000, but over here, after 12% reduction, it becomes 440,000 and the total cost becomes 840,000. Your profit will become revenue minus total cost. 1 million minus 840,000 is equal to 160,000. Okay, let's go back. What was the profit in the previous case? The profit here was 100,000 and the profit here is 160,000. So you can see that just by reducing material cost by 12%, your profit has increased by 60%. What does that mean? What's the message? The message is that if you can reduce material cost by only 12%, it would bring about an increase of 60% in profits. And that is a big increase. And therefore, the job of a material management is so important that every penny saved here would make a big difference in the profit. Now, we'll be doing the same thing, but using Microsoft Excel. So for instance, this is our original data. And as you can see, this is our original data here. So in this, you can see here that our revenues are 1 million, material cost is 500,000, labor is 200,000, overhead is 200,000, and total cost is 900,000. And this is the sum of these three costs, cost of material plus labor plus overhead, and that becomes 900,000. And then your profit is equal to this revenue minus total cost, and that becomes 100,000. So that is the profit. That's our original data. And now we are going to reduce this material cost by 15%. If we want to reduce this by 15%, what we need to do? So we will multiply this one by 85 because 100 minus 15 is equal to 85. So if we multiply 500,000 by 85, that will give us the reduced cost, and that will become 500,000 multiplied by 85% or 0.85. Okay, the next thing is to calculate profit. How much profit? And the formula for profit is equal to revenues minus total cost. The new profit becomes 175,000. Now we want to see how much change in profit has happened. And again, for this one, we'll be using the same formula, which is current minus previous and divided by current multiplied by 100. What's the current profit? Current profit is this one minus what is the previous profit? Previous profit was 100,000 and divided by previous, again that's 100,000, and if I hit enter it gives me 75%. Now there is a possibility that you might get a different number, maybe sometime you can get 0.75. If you get 0.75, just click on this percentage and it will automatically convert it into percentage. This calculation shows that initially our material cost was 500,000 and our profit was 100,000. When we reduce this material cost by just 15%, then our profit increases by 75%. And that's a big change. And that highlights the importance of reducing your material cost. Note one thing, we have different variables. We have revenues, we have material, labor, overhead. So far, we have only managed one thing, that's material. Assume a different condition whereby instead of reducing material cost, you want to achieve the same level of profit, but instead you want to increase revenue. In other words, you want to see that in order to achieve the same level of profit, instead of reducing material cost, how much increase in revenue could be carried out? We can use two methods. One is manual calculation and other will be using Microsoft Excel goal seek function. Let's do first manual calculation. In manual calculation, we know this is the formula that's revenue is equal to profit plus total cost. And it's the same formula that profit is equal to revenue minus total cost. It is just tweaked a little bit to get this revenue, which means we want to calculate revenue. And for this one, a revenue will be profit. So for example, if we want this profit, that's 175,000. Material cost is this one. Your revenue will be 1,075,000. So this calculation shows that if you want to take another route, which means instead of reducing material cost by 15%, you want to determine instead of material cost, how much increase in revenue should be carried out to achieve the same level of profit. And it says you need to increase your revenue by 1,075,000. So that's another route to achieve the same result. Profit will be this revenue minus total cost, and this is total cost 175,000, which means exactly the same thing. Now I'm going to use a different function that's called as goal seek function. And for that goal seek function, we will ask Microsoft Excel to determine that how much change in revenue should happen to achieve the same level of profit. So we know, for example, okay, if profit is equal to, over here, I will enter the formula for profit. And the formula for profit is equal to revenue minus total cost, and it gives us this one. And of course this is false because we do not have any value of revenue here, so just ignore this value. The only thing that's important here is that we want to have a formula here, and the formula that we are having here is F2 minus F6, which means revenue minus total cost. All right, now let's use goal seek function, and for that click on data in the ribbon and then what if analysis, and then click on the drop down list and then goal seek. And once you have this one, then the first thing is that it says set cell. So you set the cell where you have formula, that's for profit. It says change it to value. What value do you want to change it? We want to make it 175,000 by changing cell. Which cell do you want to change? We want to change revenues. Now again, goal seek function is that we want to adjust this profit. As you can see here, set cell is F7, that we want to adjust this one. We want to make this 175,000. This is 175,000 because that's our objective. Because when we were using material cost reduction, we got a profit of 170,000. And now we want to see that instead of reducing material cost, what would happen if we go for this route that's increasing revenues? We want to achieve the same level of profit. So I put it here, and then by changing cell, by changing this cell, revenue cell, and now I will click on OK. But before I click OK, just note, what is here in revenue? It's empty. There's blank. There is nothing. But Excel will fill it. And also here profit, there's this value that's arbitrary value. It's not true. It's false because our revenue cell is empty. So it will also change. When I click on OK, you see here it has automatically filled. It says that if you want to achieve a profit, then you need to increase your revenues by 1,075,000. So essentially, in the nutshell, we are comparing here two approaches. One approach is that's reducing material cost. If you reduce material cost by 15% with this data, then you will be getting a profit of 175,000. The alternative approach is that instead of reducing material cost, we are gonna increase our revenue. And this goal seek function tells us that if you want to go with this route that's increasing revenue, then to achieve the same level of profit, you will have to increase your revenue by 1,075,000. Then the next thing is percentage change in profit. Again, we'll be using the same formula, that's current minus previous divided by previous multiplied by 100. So how much change in profit has happened? So this is current minus original. This is our original divided by previous. Previous and original, they are the same thing, divided by this previous. And if I hit enter, it gives 75%. And again, if you are getting something 0.75, you need to click on this percentage and it will be converted into percentage. And percentage change in revenues. And that would be, okay, let's talk about revenue. And I'll be using the same formula, that's current minus this previous divided by previous or the original one. And if I hit enter, it will be 7.5%. Now, this one is essentially about comparison, which means if you want to go with this route that's reducing material cost, it would result in a profit of 75%, and that would require a reduction of 15% material cost reduction. The alternative route is that to achieve the same level of profit, that's 175,000, instead of reducing material cost, you see, we didn't reduce material cost, it was 500,000. We have here 500,000. Instead, we increased revenue, and that revenues need to be increased by 75,000. So let's make sense now. I will summarize everything here. The point here is that you have two options. You could reduce material cost, which is 15% reduction, which is a little bit difficult, but not entirely difficult, which means you can achieve 15% reduction through efficient procurement process, negotiation with supplier, and streamlining your processes. That's one option. The other option is that increase your revenues by 75,000. Maybe that would require hiring a new person, and there will be some extra cost associated with that. And for this purpose, we use goal seek function. Now it's time to wind up everything. So in this chapter, we discussed different strategies. The first strategy was make to stock, whereby everything has already been made and you just need to ship it. For example, buying a laptop from Walmart or Best Buy. The second one is MTO, whereby a company will produce that product once it receives that order. It has not already made it. And the third one was configure to order, whereby a company will make a product. It will start with manufacturing because every product is different. So your lead time will start from manufacturing. And then the next one is assemble to order, whereby everything starts from assembly. And then ETO, that's engineer to order, that's for novel product that do not exist. And for that type of product, your lead time will start from designing, which is an extensive stage. And after designing, there will be procurement of material, then manufacturing and assembling and shipping, and therefore lead time will be very, very high in this case. On the other hand, lead time will be very, very low in this case because over here a product has already been made. So as you can see here, they all have different lead times and different characteristics. Reducing material cost can significantly increase profitability. As you know, we just noted in this example that if you reduce material cost by 15% and that increased profitability by 75%. So therefore, this is the reason why the job of a material management is critically important. we navigated this option that's material cost. We also went through this option that's alternative route of increasing revenues. And for that purpose, we used goal seek function. And the last key takeaway is that material management is about reducing materials cost through effective planning and management. In other words, cash, which is the lifeblood of an organization, it depends to a significant extent on the acumen of material manager.